In example 1, we're going to be constructing a chart of data values, and then we're going to plot those to create a graph. And if you look on the left-hand side, we're given our equation right here, y is equal to 2x plus 3, and then we're also actually given values of x. So to use these values of x to find the corresponding values of y, all we need to do is substitute them into the equation. So in place of the x, we're going to substitute that x value in. So 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. So we know that the point negative 2, negative 1 is on the graph. So left 2, down 1 would be right here. Let's try negative 1. So we have 2 times negative 1, again going right back to the original equation, then plus 3. So negative 2 plus 3 would be positive 1. And negative 1 up 1 is right here. To find the y value when x is 0, all we need to do is substitute 0 into the equation, same thing we did before. 2 times 0 is 0, and 0 plus 3 is just 3. So 0, 3 is right here. And 0, 3 has a very special name. It's called the y-intercept. It's the point where the graph crosses or intersects or intercepts the y-axis. That'll happen whenever x is 0. If there's a corresponding value of y, then that is the y-intercept. Now let's take a look at the next one. So we've got 2 times 1 plus 3, and these you might be able to do in your head once you get the hang of it. 2 times 1 is 2, 2 plus 3 is 5. Alright, so 1, 5 here is going to be on the graph. And then let's try to do 2 here, so it's going to be 2 times 2, and then plus 3 again. Same thing, just the x value is changing. So 2 times 2 is 4, and 4 plus 3 is 7. So 2, 7 is a point on the graph. Now if we look at these graphs, we can find, or the points on the graph here, we can find any point if we know one of them just by going up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. So we can plot some more points here, down 2, left 1, down 2, left 1, and that'll just increase the accuracy of our graph. Kind of nice to do. You really only need 2 points to graph a line, but I find the more points you have as a guideline, the better. So we'll use our straight edge to draw a nice straight line right here, and we've got this one all knocked out. Now, what we'll do here is we have part B, so let me just move that over to the screen. Okay, and we have another equation, and I'm not sure if you can see that there. I'll write this a little bit bigger. It's y is equal to negative 3x plus 1. That's the equation that we want to graph here. And unfortunately, we're not given any x's. When you choose x values, though, you want them to be somewhere on the graph. And some are better than others, but I think here we're going to try that negative 2, negative 1, 0, 1, and 2. And if one of these doesn't work, if it produces a y value that's off the graph, you can either change the scale or just choose a better value of x. And you'll eventually find one that should be on the graph. Well, let's try the first one though. So we've got negative 3. Again, we're just looking at our equation. We're trying to find y, and we're saying, well, hey, what if x is negative 2? What's that corresponding value of y? So negative 3 times negative 2 is 6. And we've got 6 plus 1 then, which is 7. So negative 2, 7 would be right here on the graph, and that's an ordered pair that's on the line. Now we've got negative 1 here for x, so we'll do negative 3 times negative 1, and then plus 1. So we've got 3 plus 1, which is 4. So we've got negative 1, 4 here. Alright. Let's see, so when x is 0, well, let's take a look at this equation right here, and this is the same one. If x is 0, this whole term is going to go away, because anything times 0 is 0. So we'll be left with just 1. 0, 1 is, in this case, the y-intercept. If we try 1 here, we've got negative 3 times 1 plus 1, which is negative 3 plus 1, or negative 2. So we can go right 1, down 2. And these points are lining up in the same manner that they did before in the other example. They have a different slope, but how to get to each point is the same. So down through your right one, down through your right one, down through your right one. We're expecting the other point to be right here. Let's figure out if that's actually the case. So we'll do negative 3 times 2 plus 1 is negative 6 plus 1, and that's negative 5. So 2, negative 5 is in that right location. I don't think we're going to be able to fit any more on this one, so we'll just go ahead and draw ourselves a straight line here, and maybe that's not, marker isn't showing up real well. Might have to get some new markers here. But there you go. So each one of these examples is an example of how to graph a line using a t-chart or a table of values. And you'd utilize that table by choosing values of x if you're not already given those values and substituting them in to find the values of y.